delegate function and
We're gonna have delegations in the final?
sorry?
Are we gonna have delegate in the final?
Yeah, of course. Is there anything wrong with the delegates?
I just don't fully understand.
Oh, you forgot the lecture that we had discussed this one? It's basically nothing, it's just like a function, you know. It's a function that will return an integer, like, you know, this delegate will point to a function that would have same signature as this one,
Okay.
even including the return type. So delegate int del. So I have defined this as a delegate. It can be now assigned a function that should have the same signature, accepting value. And again, you remember, returning or not returning, it's not the problem. It has to accept one
So
integer.
I see you made an instance of that.
Yeah, so then we have created its instance with our name, and typically we have allocated a function to it, which comes up as an expression here, but it's actually a function.
Yeah, returning the value of those
Yeah,
Ys.
so what it will do is that it will pass this y to this, you know, so to speak, function, multiply that, and it will return a value. So again, so this is basically the value of this my delegate, and then when I say int j is equal to my delegate of 5, so when I pass a value, so actually I'm calling this statement. But what it does is that it goes the way, like, you know, we discussed that it goes away, that delegate points to function and calls that function. So it's actually, I'm calling this function, but by using this my delegate, which I have created over here. And again, if you remember, we saw it's one of the example when we were doing its examples in, I think 3 weeks back or 2 weeks back? 2 weeks back. So we were looking at the example that there were multiple function, we defined a function to promote or something, and then we passed that function to the delegate. So again, and I told you that now if you just change the logic of the function, just passing and running will be always in the hands of the delegate that we talked about. So again, this delegate here is doing nothing special. A delegate being defined as a reference, and it has been given, again, what we are looking at, it has been given a lambda expression. And what I would say is that more than lambda expression, it's a lambda function, by the way. Again, the arrow function that you say, the arrow function in JavaScript, right? So it's just accepts that one, and then of course when this will be called, it will return something, because it's a function that has and by the way, this is very interesting, and someone who understands the arrow function will understand how this line of code is working. Because this is quite, actually this statement, I think I discussed that at that time as well, but I'll just, you know, give one more hint for that. This is actually the equivalent of this function. Function y return y multiplied by y, the JavaScript function I'm talking. By function you can name it, and you know that JavaScript has this facility. I can say ABC equal to. So I can just assign that as well. You know, it can be a expression. Actually, this is the function written over here. Does that make sense? And you know how come it is written over there? That when we convert a normal function expression or a declarative function, so to speak, if we convert them into the arrow function, the first thing goes is these the curly brackets. So for example, one another thing, the function keyword goes, and these two, not curly bracket does not go, but rather I'm just maybe wrong. So this function keyword goes, and it becomes this one, and this function keyword is replaced. Let's write that is replaced with this one. Function keyword is replaced with this one. You would have seen that transfer. Now, when you have only one statement in a function, and you know it's general rule for most of the if there is only one statement, you can even leave out this one. So it does not go here, it goes here. So now it becomes something like this. and up to the level that when you have a single statement that is returning from this lambda expression, from the arrow function, you just take out the return keyword. And even, at some of the implementations will say you no even need for the parenthesis, because we know if you are using an arrow after us, we know that this is a parameter and you want to write a function. So this function now ultimately becomes this. But again, the exception is that it has to be a single statement, and another exception is that it has to be a return statement, which is returning the value, maybe, it's returning the value. So now this function, so it's the function, so it's a complete whole function that has been written over here. So delegate actually looks for a function. Delegate getting the function, and now if it is getting the function, it will just execute that one, and so again, when you want to access that, you will have to call that with the name of delegate. So we are calling this function by using delegate, by passing a value. So this y5 becomes the value of y rather. And when it becomes a y, so it will multiply and return a value of 5. That return value should be caught over here, and that would be caught, and that's the value that it is showing 25 or whatever. We can just change the value, and we can. So here, what we are looking at this lambda expression that we have written now. So is it lambda expression, lambda function? You can just use both of them, and you can just work with any one of them. Make sense?
Mm-hmm.
Right. All right, let's see one more example, then we'll move to the other part of it. There's one more syntax that you might want to use here. Let me just show you.
For a free cut?
So let's take it. So there's one more syntax that we can use with these queries, like with expressions, lambda expressions. So let's see lambda 2 here, because I would be using another lambda expression, but with some difference. Here, let's see. We have a it's a Fibonacci series, we'll see it's summed by using one of the method that we can use in C# as well, which we have not used, or the where syntax maybe. So you see what it's doing, that fibnum dot where. So again, here we are just giving a where, but with a lambda expression. So just passing a lambda expression, that num, take the number and take it remainder with 2, and if it is equal to 1, so again, all those numbers which are represent. And now what it will do is that it will just calculate their average by using this average method, and should display the average of these Fibonacci numbers. We can limit it to fixed and something now. So lambda expressions is interestingly, this is the one that lambda expression works with, right? So now let's, after the lambda expression, what else we have? So a lambda expression with a query operator is evaluated the same upon demand, continually works on each of the elements, input sequence and the whole sequence. So that's what we have seen, that where that would work in the where, and it will just bring up that standard query operator. So we have this where is the standard query operator, dot where, that is the standard query operator. This is very interesting, and this might be the last, or this is the expression tree. Variable scope. It's interesting that variable scope is quite interesting. When employing variable scope in a lambda expression, several rules come into play. First, variables initialized within lambda expressions are restricted from visible in an outer method. So interestingly, the variable scope is an interesting issue when it comes to the lambda expression. So again, the variables initialized within a lambda expression are restricted from being visible in an outer method. So if they are somewhere in a method, they would be not visible, restricted outside of that. We'll see an example. Another rule pertains to captured variables which are not eligible for garbage collection as long as the delegate referencing them remains in the scope. So again, garbage collection will be an issue when we have a delegate. So we'll see a delegate example. We'll create a delegate function, and we'll just try to assign some lambda rules over there. So when we'll see that when some delegate referencing will be there, so they might not be deleted as with the garbage collection. We might not need to do something. Furthermore, lambda expressions are bound by a rule that prevents a return statement within the lambda from causing the enclosing method to return. So again, there are certain interesting rules to follow when it comes to the scope of a variable, scopes of the variable with respect to lambda expressions, because we know that when we define a function, it has a very limited scope. It's when we say x arrow x into x, y arrow y into y, we are limiting that scope over there. But that scope, how does it affect? Let's see another example, and this will be our example code for that one. Let's come back here, and again, let's add one more set of same. So this is related to scope of variables, so I'll say BTN scope. And then the same goes here. So we have defined two delegates, and now I'll go by class, which we have used departments, and there I'll just create another class, class there, because I want to use it over here. after this class, I want to create another class, public class, and let's call it test. Okay, so they are not visible here, so I'll take my, the delegates to this class definition. I can then define them public as well. You just come here and define them over here. So I've just defined them in the class we will be able to do. Let's not return and to console.log. So we want to check something. go to this, let's go click. So just change this to public delegates and vote. Let's make it, because if you're consoling us also, because we want to see some of the outputs in the console. So this is from one if someone is looking. I'll just run these in a bit.
These guys. No, no. This is problem. Oh, yeah.
I don't know why this is coming from those guys. You gotta make them appear public too. Oh, I did. Oh, okay. I wanna check this. Unnecessary.
Alright, let's run that. So it gives J0, J10, bool result true, and the result is coming out as true. And we'll see that one. So it's basically giving J is equal to 0 for the first one. So you see when this is invoked, del, it does not change the value, right?
Mm-hmm.
But when this is invoked here, then the value of j changes to 10.
Yeah.
Right? So it's basically doing what? Again, j has been assigned a 10 while we are just allocating that one. So you see that j is actually not defined inside this this lambda expression. Where here we have used typically the lambda functions by themselves, right? So the lambda function j is equal to 10, then it is returning a true or false, of course, because its definition is saying that, you know, if you look at the delegate definition, there that would be returning a bool value. So, but it's here, what it's doing that it's allocating j is equal to 10. And then when we have this del2, which is taking a parameter and checking the parameter, if it is equal to j, then it returns a value. So again, so if you see that j equal to 0, the first output that is coming out is j is equal to 0. So what it is doing is j is up to its initial value. It does not change over here. But then when we have this function that is called, when we have called the del2 from here, so what has happened that let's check with x with equal to 2. So we have what we have passed there as x. If you look at that, we have just passed there 10. So it checks with that one, and if it returns over there true, and the value of j is now turning out as the 10. So that's typically, you know, the behavior that, you know, even though that it has been defined, it has been called with delegate, like, you know, the lambda expression, but still it is just not accessing that one. So now it is okay. So now the last topic is expression tree. That might be, I'll just, you know, discuss that. We might not be going into its details. So lambda expressions play a significant role in extensively constructing expression tree, which represents code in a data structure that resembles a tree where each node is an expression itself, such as a method or a method call or a statement or something. So again, lambda expression, it's typically it can be used, or, you know, to have an expression tree, as we discussed in the beginning, that it goes in the tree format where you'll have different levels of that tree. So every like, you know, each node represents an expression that would expressed out, that would be evaluated to a value. Expression means everything that evaluates to a value. Then we have statement lambda. There is also statement lambdas consisting of 2 or more 3 statements, but are not used in construction of expression trees. A return statement must be written in a statement lambda. Binary operations like x is less greater than y. So statement lambdas are where they do not become an expression, or they are not used in the construction tree. So again, they might not be like, you know, they are not evaluating to a typical value. Rather, they are there to just, you know, have a like, you know, the tests of some kinds. You know, we are just, you know, having this tests of some kinds that would be expression tree. And it's a statement is again just as we have seen that the parameters will pass on, and then we have the statements that we have seen, sort of like, you know, the statement lambda or the lambda function that we usually talk about. That's typically the one that we have. So again, we are stopping here. We have seen certain examples of that one. This code will be available to you, and so now what we'll do, that we'll just start. So there's one more thing that I'll just share as a like, you know, video link, the SQL basics and everything. So I'll be sharing that as a video, like, you know, as a video link with you guys, and this code and everything will be available. Now we'll just take a 10 minutes break, and we'll start our like, you know, in class 5, the last.